Were you able to identify the buffers in this list? So let's go through them one by one. Letter A, you have 50 ml of zero point 0.2 molar hydrochloric acid and 50 ml of zero point 0.2 molar sodium chloride. This is not a buffer. Why? Because your acid there is not a weak acid. HCl is a strong acid. Even if we find the conjugate base of HCl, which is the chloride ion from sodium chloride, this will not lead to a buffer. Letter B, 50 ml of zero point 0.2 molar nitrous acid plus 50 ml of zero point 0.2 molar sodium nitrite. This one is a buffer. It's because nitrous acid or HNO2 is a weak acid. And we have its conjugate base, nitrite or NO2 minus from this salt, sodium nitrite. Let's go to letter C. 50 ml of zero point 0.2 molar acetic acid plus 50 ml of deionized water. Mixing these two will not give you a buffer. It will only give you a diluted solution of acetic acid. In fact, what you will end up with is 100 ml of zero point 0.1 molar acetic acid solution. It's not a buffer because you have a very small, very, very small amount of the conjugate base acetate. This acetate will come from the dissociation of acetic acid. But this concentration of acetate is not enough for you to form a buffer. So letter C is not a buffer. Letter D, 50 ml of zero point 0.2 molar acetate plus 50 ml of zero point 0.1 molar sodium hydroxide. This will form a buffer. So if you were able to watch one of the videos on buffer preparation, it's possible to prepare a buffer with only one of the components if you have a strong acid or a strong base. So in this case, you will still end up with a buffer because 50 ml, if we multiply 50 ml times zero point 0.2 molar, this will give you 10 millimoles of acetic acid. And 50 ml of zero point 0.1 molar sodium hydroxide will give you 5 millimoles of hydroxide ions. So you see that this strong base, the hydroxide ions, can neutralize 5 millimoles of the weak acid, acetic acid. So you will end up, so 5 of these will be neutralized. So you will form 5 millimoles of acetate, and you will be left with 5 millimoles of acetic acid. So just divide this by the total volume, which is 100 ml, and you will get the final concentrations of your two components in the buffer solution. So this one, letter D, is a buffer. And letter E, 50 ml of zero point 0.2 molar ammonium nitrate plus 50 ml of zero point 0.2 molar sodium hydroxide will not give you a buffer. So yes, you have the strong base so that you can form the conjugate base of ammonium here from ammonium nitrate. However, you have equimolar amounts of the two. So the ending is you will convert all of your ammonium ions to ammonia. You will not be left with ammonium ions. You only have ammonia. So you don't have the other component. So letter E is not a buffer. So as a summary, we have solutions B and D as our identified buffers, while solutions A, C, and E will not give us buffers.